All right, for this problem, we are doing the limit of h approaching 0 for the function f of x equals square root x plus 1. And the definition we are using is f times x plus h minus f of x over h. So we're going to start by plugging in our function into our given definition. So we are going to have the limit of h approaching 0 as, let's start with parentheses, root x plus h plus 1 minus root x plus 1 in parentheses all over h. Now we're going to want to multiply this by the conjugate. So the conjugate is going to be, first let me note before we do the conjugate that a couple things are going to be canceled out. You will notice that we are distributing a negative to our square root of x and our 1. This becomes negative 1, and with a positive 1, that is going to cancel out. So that is the only thing to note here. So our conjugate is going to be root x plus h plus square root x over, and the same thing, we're going to multiply our denominator by our numerator conjugate. So same thing on the bottom, x square root of x plus h plus square root of x. Let's move down a page for this. So with that multiplied, you'll notice the limit of h approaching 0. If I go back up for a second, you're going to end up square rooting, or you're going to end up with the square of what we had for our numerators. So we're going to keep that in mind when we're down here. So now we're going to have the square root of x plus h squared minus the square root of x squared all over, and then for our denominator, we're multiplying our individual h by our conjugate. So we are going to have h times root x plus h plus root x. Alrighty, so now the next thing we are going to notice is that with a square root and the figure being squared, they're going to cancel out. So now we have limit of h approaching 0 as x plus h minus x all over h times our conjugate, which again is the square root of x plus h plus square root x. Alrighty, a couple more things are going to be canceled out now. You're going to notice x minus x cancels each other out. And you can cancel out our h's that are right there, but you're going to have to substitute your numerator with 1. So let's cross those out as well. And we're going to rewrite our limit of h approaching 0 as 1 over. And so now this is where we'll look at our denominator before writing this. So if we input our value of 0 for h, what is that going to give us? It's going to give us nothing. So that means writing in our denominator, we are going to end up with our 2 square roots x. And these 2 can be simplified to equal 2 square root x. So that is what we are going to have as our denominator, 2 square root x, since our value of 0 does not produce us any other number. Therefore, our answer, what we are looking for the limit of h approaching 0, is the f prime, or derivative of f. So we can write this as the limit of h approaching 0